So life uses 20 building blocks to make these molecules known as proteins. Now, everything is made of proteins. You, me, bacteria, everything is made of proteins. So the fact there are only 20 building blocks at first sight might seem surprising, but then remember that everything that has been written in this library in the English language has been built of 26 letters. Very good analogy. So the question then is, what would be a good set of letters, whether it's biochemical or English? And in fact, at one point when I got stuck with this research, I collaborated with some folk in Sweden who were asking similar questions about the alphabet of sounds that we make. And we brainstormed with each other, what makes a good set of building blocks for language? Our hypothesis in the end was that you wanted building blocks that span a broad range in key properties that are related to the functions that you might want to build later on. I'll give you a simple example, size. You'd want to span a broad range of size from small to large. But you'd also want to try to space the options equally between the extremes, so that at any given moment, when you're called upon to find an amino acid of a particular size, you can approximate it, rather than have them all bunched up, very big, very small. So a very simple hypothesis. We want them evenly spread across a broad range in properties that we know are important to building protein molecules. That was what we tested, and we found out that it is very difficult to pick a set of 20 building blocks that are better spread across a broad range in the properties that we know are important than the ones that nature is using. In other words, we interpret that as a sign that natural selection picked a set of building blocks that were evenly spread over a broad range, and there is no accident to the building blocks that life is using.